So once again, to start, even though I didn't have the video recording, we are going to deal with exponents of lots and lots and lots of different numbers. It doesn't matter. You can have anything be an exponent. Okay? And you got to follow the rules. So if I'm multiplying two things with the same base, and all of these, the base is the same. You multiply, you add the exponents. You divide, you subtract the exponents. When you raise a power to a power, you multiply the exponents. Okay? If I have a negative exponent, and these are the ones that tend to trip students up with these ones here. If I have a negative exponent, think about the fraction bar as this magic bar that if I have it above, because technically a to the negative n, this is over 1. I want to get rid of my negative exponent. What do? I move it down to this denominator, and it becomes positive. If I have a negative exponent in my denominator, I move it up to the numerator, because this is technically over 1. Move it up to the numerator, and it becomes a positive exponent. Okay, that fraction bar changes the sign of your exponent as you move up and through. We don't want negative exponents in our answers. So one of the things we don't like is we don't like negative exponents. So we may have to move something to the denominator or move something up to the numerator to get rid of our negative exponents. A to the 0 power is 1. Anything to the 0 power is 1. And this is why. Okay, this is why. I can do a quick, simple proof. And I'll actually pause. Okay. When I have two things multiplied, raised to a power, I can raise them each. Notice this is multiplication, not addition or subtraction. I can distribute powers across multiplication. You cannot distribute across addition or subtraction. If I have two things divided to a power, it's each one of them to that power. Once again, notice it's division, not addition or subtraction. Exponents can be distributed, which is what we're doing here, across multiplication and across division, but not addition or subtraction. Okay. Now we get into the new stuff, which really can get kind of hairy. Fractional exponents. You're going to have to be able to go back and forth between radicals and exponents and radicals. Fractional exponents are actually very easy to handle, and it's much easier to solve problems in exponential form than it is in radical form most of the time. And we're going to be solving equations in exponential form. You have to get comfortable with understanding exponents. So I have a to the 1/2 power. That's equal to the square root. What is my index? What is my index on the square root? My index is 2. Notice the connection between the exponent and the index on my radical. Okay, a to the 1/3 is the cube root of a. Cube root of a is a to the 1/3 power. Okay, if I have an index of anything, that gives me that. So if I write a fractional power, my denominator is what root I'm taking. Okay, if I have something in the 1/4 power, that means I'm taking the 4th root. If I have something in the 1/8 power, that's an 8th root. Okay. Same thing goes on here, and I can combine our rules of exponents. If I have a fractional exponent with a numerator and a denominator, my denominator is my root, my numerator is my power. So if I have a to the m over n, that's a to the mth power over with the nth root. My denominator gives me my root. My numerator gives me my power of my object, whatever the base is. So I can take any radical, I can take anything and rewrite it as an exponent, any radical. I can take any exponent, rewrite it as a radical. Okay. So, let's look at some examples. Oops. Yeah, it goes straight into you trying it. Okay, these are all fairly simple ones. Okay, give them a shot following the rules. What do the rules tell you to do with the exponents? Add them, subtract them, multiply them, divide them. So that's what this part here is all about following the rules. Our answers do not want to have negative exponents. If you have a negative exponent somewhere, get rid of the negative exponent somewhere. Okay? Okay, let's do these. So the first one, x to the 5th times x squared, you add the exponents. So I get x to the 7th. The next one, x to the 5th raised to the 2nd power. When you raise a power to power, you multiply the exponents. X to the 10th. Next one, divide. You subtract the exponents. 5 minus 2 is 3. When you get to this one, x2 minus 5 is negative 3. But we don't want negative exponents. I want positive. So to take it, make that negative exponent a positive one, I move it down to the denominator. 1 over x to the positive 3. Now, one of the things that I will do, and I'm okay with this if you do it, is you go, okay, I subtract when I divide, but my larger number's in the denominator, so that means my answer is going to be in the denominator, and I just subtract them. 5 minus 2 is 3, but because the bigger one's in the denominator, I put my answer in the denominator. That will also work. I'm okay with that as long as you get it correct. So the whole object of the next one, once again, get rid of the negative exponent. So this is 1 over x to the 5th. If I have a negative exponent in the denominator, I just move it up to the numerator and get rid of it. Okay. What is x to the 0 power? 1. Ooh, good. 2xy to the 5th. That means that I have 2 to the 5th, x to the 5th, y to the 5th. Because it's multiplication, I can do that. Now, you should not leave 2 to the 5th as 2 to the 5th. You should rewrite this as 32x to the 5th, y to the 5th. Just, it looks better that way. The numbers, you want to do the powers and stuff on the numbers when you can. The variables are actually easier on this stuff because you just write them to their powers. You don't have to do any other manipulation. The numbers are always where it gets stuck. Same thing on the next one. It's multiplication and division. Anything that's in there, because there's no addition or subtraction, everything that's here, I get 2 to the 5th, x to the 5th, y to the 5th. Everything gets raised to the 5th power. I feel like Oprah. So I get 32 x to the 5th over y to the 5th. Everybody gets the 5th. You get a 5th power. You get a 5th power. Sorry. Okay? Does that make sense? Questions on this page? Fairly simple. And you may have things that are more complicated. Just do it step by step. Okay, ooh, I have this thing's all multiplied. So I distribute the powers, and then I'm multiplying them. So now I add exponents and like things. If you do it step by step and follow the rules, it's really easy. You have to know the rules, and you break it down and do it one piece at a time. Don't try to do everything at once. Okay. Fractional exponents. Simplify each fractional exponent. So the idea here is we're going to come up with a single numeric value. Okay. And you need to know how to do these by hand, but you can also do these on your calculators. But you do need to understand how to do them by hand. And what does each part represent? So when I have 8 to the 2/3 power, the 3 in the denominator means I'm taking the cube root. The 2 in the numerator means I'm squaring it. And I can do it in either order. It doesn't matter. I can do the cube root first, or I can do the squaring first. Personally, I'm going to go ahead and do the cube root because that gives me a smaller number. But I can do this either way. Okay, it goes either direction. I can either take the cube root or I can take the power first. It doesn't matter. So when I do this, this is really the cube root of 8 squared. That's another way of writing it. Now we're going to do that more later, but that's the idea of what we're doing here. The denominator is a root, the numerator is our power. So if I take the cube root of 8, that means I have 2. That takes care of the 3, so I have 2 squared, which gives me 4. 8 to the 2/3 power is 4. cube root from the denominator. 8, the cube root of 8 is 2. Take that number and square it, I get 4. Same thing on the next one. The fifth, 27 to the 5/3 power. The denominator means that I take these cube roots. The numerator means I take it to the 5th power. I'm going to cube root first. The cube root of 27 is 3, so that's 3 to the 5th, which is 3, 9, 27, 81, 243. I just wanted to make sure that in my head before I did it. Okay. Well, I wanted to go through. I'm glad you did that, but I was like, I want to make. So I thought it was 243, so running through it in my head. I know some of my power is pretty good. That's one of them. Ooh, the next one. What do I have in this exponent that I didn't have in the previous two?
Negative.
Negative. All that means is it's 1 over 4 to the 3/2 power. So do that. Put it 1 over that, then solve it. 4 to the 3/2 power. The 3 means I cube, and the 2 means I take a square root. What's easier, cubing or square rooting? Square root's going to give me a smaller number, right? What's the square root of 4? 2. So this is 1 over 2 cubed, which is 1 over 8. Every one of these is going to come out to be something like this. Okay. Same thing here. Only its negative is inside. The negative's not part of the exponent. This is not 1 over that. That only happens when the exponent's negative. The exponent is not negative. The exponent's positive. The 32 is negative. Okay, so 4 means I raise it to the 4th power. 5 in the denominator means I take the 5th root. Now, I could do that. I could take negative 32 to the 4th power and then take the 5th root of that. But if I take negative 32 times negative 32 times negative 32 times negative 32, I'm going to get something really, really, really big. And then I got to figure out what the 5th root of that is, and that's a pain in the butt. But 32, we worked with 5th roots of 32 a couple of days ago. 5th root of 32 is 2, so this, or sorry, negative 2, so this is negative 2 to the 4th power. Okay. And then I take negative 2 to the 4th power, 2, 4, 8, 16. Let's talk about how to do this on your calculators. If you got your calculator, get them out. If you don't have a calculator, get your hands on a calculator. Because you ought to know how to do this on your calculator. You can do any roots and any power you want on your calculator. On my calculator, you're going to use the caret key. We talked about this the other day. Let me slide this up a little room to show you what you're going to do on these. Okay, so we talked about the caret key. That's the power key. It lets you raise a number to any power you want. Okay. You may also have, your calculator may have a y to the x key. It does the same thing. Okay, it raises it to a power. Here's the trick when you're using fractional exponents. You must use parentheses around your exponent. You must use parentheses around your exponent. So if I want to do the next one, 16 to the 3/4 power, here's what you do. You do 16, and then you hit either the caret key or the exponent key, whichever one you have. Parentheses 3 divided by 4, end parentheses, and then equals. You should get 8. Get 8? Okay. If you don't put parentheses around it, here's what's going to happen. Your calculator, if you do not put parentheses, your calculator is stupid. They are like a petulant child. They will do exactly what you tell them to do and only exactly what you tell them to do. You ever have a 5-year-old that's kind of ticked off and they say, pick up your clothes? And what you really mean is to pick up your clothes and put them away. But all you do is say, pick up your clothes. What do? They pick up their clothes. Now what? What do you want me to do now? I picked them up. What do you want me to do now? You know what I'm talking about, right? Okay, your calculator's just like that. If you don't put the parentheses around it, what it'll do is it'll take 16 to the third power and then take that and divide it by 4 is what it will do, because it follows the order of operations strictly. An order of operations say exponents, and then you do division. You did not say that. That's why you put the parentheses around the 3/4. You're telling it, hey, your exponent is 3/4, 3 divided by 4. Here it says, oh, I'm going to take 16 to the third power, and then I'm going to take that and divide it by 4. If you don't put the parentheses around it, it won't come up right. The parentheses are important. Okay, when you're typing into your calculator, you got to remember that, because otherwise your calculator will. Because calculators do exactly what you tell it to do. They follow order of operations perfectly. And you have to understand that. Okay, do the next one. Do that on your calculator. 8 to the negative 4/3 power. And like I said, type it in. Don't forget the parentheses. Don't use the subtraction key. Use the negative key. They are different keys. Calculator will freak out if you use the subtraction instead of a negative. It will say syntax error or error, which is stupid. You typed it in wrong. And you should get 1/16, which has a decimal. What? Half of 1/4 is 0.25. Half of that is 1/8, which is 0.1. No, 1/8 is 0.125. 0.0625, I think. I think it's 0.0625. But once again, do I want decimals? No, I want whole numbers. And hopefully your calculator will spit it out as a fraction rather than, and the calculators, by the way, will have to subtract fractions for you. You know that? Do you know that your calculators will add and subtract and multiply and divide fractions for you? There's a fraction key on your calculator. Your fraction key usually looks something like that, A with a little thing, or they'll have it as 3 as a mixed number. So if you want to put in 1/8, you hit 1, hit that key, and then 8, and then equals, and put 1/8. We'll have a little hook thing that tells you that's a fraction. And it will do that. You can type in fractions. I generally don't, but you can. Okay. Your turn. Do those. Okay. So the first one, 49 to the 3/2 power. The 2 in the denominator is take the square root. Square root of 49 is 7. So that gives me 7 cubed, which is 343. Next one, I have 4 to the 5/2 power. The 2 in the denominator means I take the square root. So that gives me 2 to the 5th, which is 32. The next one, I know you guys haven't written down on your paper, it's negative 1/3. So this means I have 1 over 27 to the 1/3 power, which means it's the cube root of 27, 1 over the cube root of 27. So this gives me 1/3. Okay. Next one here, I take the cube root. The denominator means I do the cube root. Cube root of negative 8 is negative 2, and then I square that to give me positive 4. 9 to the negative 1/2 power means I have 1 over 9 to the 1/2 power. 9 is the square, 1/2 is the square root. So this is 1/3 again. And then 16 to the negative 3/2 power means that I have 1 over 16 to the 3/2. The 2 means I take the square root. So that gives me 1 over the square root of 16 is 4. 4 to the 3rd power, which gives me 1 over 64. Questions? Okay, these ones are just strictly rewriting them as an exponential or taking the radical, writing it as an exponential, which means I'll have fractional powers. Okay? So square root means that I have a fraction with a denominator of what? What's my index on a square root? What? 2. Square root has an index of 2. That means that this is x to the 5/2 power. The power is my numerator, the root is my denominator. So the next one, m to the 4th root of m cubed is m to the 3/4 power. The exponent is my numerator, the index is my denominator. If I have more than one thing, if I have a cube of more than one thing, remember, I can take these and split them up. This is the cube root of 7 and the cube root of y squared. I can split up my roots. We have a rule. That was one of the first things we did this chapter. Was we talked about, oh, you can split them up. You can put them together or you can split them up. Which means I have 7. My denominator is 3. What's my numerator? 1, because it's 7 to the 1st power. And then I have y. My denominator, once again, is 3. My numerator is 2. Y to the 2/3. 7 to the 1/3. Y to the 2/3 power. Okay. And then on the next one, it's the same thing. I'm taking the 5th root of everything, so I have everything to the 5th root. So I have a fraction where I have a denominator 5 for every one of those terms that's in there. So if I have 2, 5th root of 2, well, that's 2 to the 1st power. So that's 2 to the 1 over 5. C squared, so that means I have c to the 2/5 power. D to the 4th, that means I have d to the 4/5 power. That's it. Just rewriting it as a fractional exponent. Why would I want to do that? Because there are things that we do in mathematics that dealing with a fractional exponent is something you can work with, and working with it as a radical, you can't. There are specific things. My calculus students, one of the things they have to do, they have to take the derivative. You can't do things that we do in calculus with radicals. You have to make them fractional exponents. When you make them a fractional exponent, it's a huge piece of cake. As a radical, you cannot manipulate it the way we need to manipulate it in there. So they take every radical and make it an exponent. That's what we do. And then we might put it back when we're done, but when we do the work, we have to make it a fractional exponent to do the work. Okay. Your turn, do those. Okay, do these. So, root is my denominator. My power of y here is 1. This is y to the 1/3. The square root of a to the 4th. Rewrite it as a fractional exponent. A to the 4/2. What is, and what do we always do to fractions? We reduce and simplify. What is 4 over 2? 2. So this is a squared. Yes?
What's the first one will be 3 over 2?
Oh, yes, you're right. You're right. My bad. I screwed up. My bad. Thank you for pointing that out. I saw the 3, and for some reason I thought that was a cube root. My mistake. That is an index of 2, y over 3/2. Thank you for catching that. My bad. Okay. But that's kind of what we were doing when we were simplifying our radicals. With the variables, what did we do? We divided by whatever the power was. That's what I just did. I just took divided by the power. That's why the square root of a to the fourth is actually a squared. We're simplifying the fractions. Okay? So I do the same thing here. N to the 7 over 3. N to the 7/3. Okay? Same thing here. Each one of these is going to be over the fifth. They're going to be a fifth because it's that. Take whatever exponent is there, put it over 5. 3 to the 1/5, c to the 4/5, b to the 8/5. And on the next one, because my index is 3, they're all thirds. So I have 2 to the 1/3, x to the 5/3, over y to the 4/3. Okay? Piece of cake, right? Okay. Do the same thing in reverse. That's what we're doing here, doing the same thing in reverse. So on the first one, my denominator means that I have a root of that index. So I have a fifth root of c squared. The numerator is my power, my denominator is my index. So my denominator 5, so that means I have a fifth root of c squared. Okay. The next one, the fractions are the same. So the fractions have the same, I should say the fractions have the same denominator, which means everything in there, all it's the same denominator in all the fractions. That means my root, I have a root of everything that's there. It's the 7th root. So I have the 7th root of 2 to the 1st power, m to the 3rd. Denominator gives me my root, the numerator gives me my exponent. Now the next one is negative. Don't like negative exponents. I'm going to take care of the negative exponent first and rewrite that as x to the 3/2 power. And then take that, get rid of the, and then get rid of the fractional exponent and write it as a radical. So the 2 means that I have a square root. It's square root of the 3 means x cubed. So that's 1 over the square root of x cubed. Okay. Denominator gives me my radical. My numerator gives me my exponent. Okay. Questions? Do those. Okay. Let's finish these up. So to the 1/6 power, the denominator means that's my radical. My numerator gives me my exponent, so I have b to the 1st, but it is the 6th root of b to the 1st. The next one, I have several fractions, but every one of my fractions have the same denominator. So the denominator means that I have a 4th root. So I have a 4th root of 3 to the 1st, y cubed, z to the 5th. Next one, I got a negative exponent, which means I have k. I have 1 over k to the 2/3 power. The 3 in my denominator means it's a cube root. The 2 in the numerator means it's k squared. So it means I have 1 over the cube root of k squared. And the next one is extremely similar. It's negative, so once again it goes into the denominator. 1 over g to the 1/5. And the 1/5 power means I have the 5th root of g to the 1st, 1 over the 5th root of g. Okay? Yes?
Will there ever be one where they don't have the same denominator?
I don't think that happens in here. It is a real possibility. And what that would be is you would just have 2 separate roots, one for each denominator, and you wouldn't be able to combine them up. You can if their bases are the same. So like if I have x to the 1/2 power times x to the 2/3 power, well, what do? You add the exponents. You have to take 1/2 plus 2/3, figure that out, figure out that fraction, and that's your new x to whatever your new power is. You can't do that. I don't have you do that in here. That's something you do at a higher level. That is, but being able to understand that is an important concept we're getting here. Now, before we're done, I want to show you something, and it'd probably be good for you to write this down so you can understand what we're dealing with. So I had you simplify radicals. Let's say I've got the 4th root of x to the 11th. And you had to simplify that. That was a quiz you just got back, right? Things like this on it. So what did I say to do? I said take 11, divide it by 4. 4 goes into 11 twice with a remainder of 3, right? So that means you would have x squared and a 4th root of x cubed. If we do this using fractional exponents, you can see kind of how that works. There's another way to see how that works. So if I take the same problem, okay, rewrite that as a fractional exponent. Okay. X to the 11/4. Now, here's something I absolutely hate, but it makes my point really good. Rewrite 11/4 as a mixed number. You know, like 2 1/2, 3 2/3, that kind of thing. Rewrite that as a mixed number, x to the mixed number power. So what is 11/4 as a mixed number? 2 3/4. 2 3/4. Now 2 3/4, even when you say 2 and 3/4, 2 and 3/4, that's addition, right? Right? 2 and 3/4. So this can be rewritten, bear with me, following the rules of exponents, as x squared times x to the 3/4 power. Right? Because what do? You add exponents. So x to the 2nd power plus x to the 3/4 power is x to the, or sorry, 3/4 is x to the 2 3/4 power, right? Okay, well x squared I don't touch, but I can rewrite this as a radical. X squared to the, and then x to the 4th root of x cubed. Rewrite that as a fractional power. I get the same thing. And this is what you do. What do you do when you rewrite? What do you do when you write a mixed number? You take the numerator, divide it, put whatever you get in front, and your remainder stays on top, right? Well, that's exactly what I had you do. I had you take 11 divided by 4 and get your remainder, and then whatever's left over is still part of the fraction. And then just rewrite that as numerator. So 2 ways of looking at the same thing. I explained it one way, but this is really what you were doing. What you were really doing is this. Rewriting it, splitting it up into 2 things that were multiplied. X to the 2nd power times x to the 3/4. So I get x squared to the, and times x to the 4th root of x cubed. That's really what you were doing. And the rules of exponents is what you were doing, but I didn't use the rules of exponents because, frankly, it's a pain in the butt to do it that way. But that is what we were doing. Okay, do you see what I'm saying? When you divide it, when you take it, divided it, you get whatever with the remainder of what? Well, that's how you come up with a mixed number. Whatever goes in plus your remainder. Same thing that we did here. Okay?